So today we are covering split plot designs and in general factorial designs within ARM. We're going to go through kind of the basic how to set it up, both in the protocol of just getting the design established as part of the plan in the protocol. Then we'll look at the trial map, especially for a split plot design, to see how you can set up your map. And then we'll also see a little bit of the analysis with an example trial, just to see the reporting side of things as well. So I guess just to dive in, I'm just going to switch over to ARM, and we will create a new protocol. And the kind of the first step here when you're creating a new protocol, you don't want to dive in and get into the protocol too quickly. With a multi-factor design, you want to stop here with your checklist and make sure that we change the study design. The default in ARM is RCB. That's far and away the most common. So that's the default, but you do want to stop here then, and we'll change that design and get things set up. And one reason we want to do that right now is it does impact the treatments editor primarily. So the treatments editor will be set up a little bit different for us in a multi-factor design. So that's the reason to do it now before we are actually into our protocol and things have to move around. I'm just going to click on our study design, and that brings us to our protocol settings, specifically to the design tab. So we do have a lot of different designs available in ARM. The ones we are going to focus on would be these last four. These are multi-factor designs, the ones that we have available in ARM. So the most basic would be your factorial, and I'm just going to click on one of them here just to define multi-factor for us. The idea here in this design is that you have two or maybe three topics, categories, if you will, called factors that you're looking at when you're setting up your treatment list. And so the goal is to cover every combination of those categories or those factors together. So in my example today, we'll say that I've got different tillage types that we're interested in researching. I'll say three different types of tillage methods, techniques that we're curious about if that has an impact on how our products perform. And specifically, I'll have four made up herbicide products that we are interested in looking at. And so what we want to do is check every combination of our tillage types and our products. So you end up with this multiplication of the different combinations. So I want all four of my products to be each on those different tillage types. And so that's really the goal. When you're in your mind, you're starting to multiply out to make sure every combination of things are together once in that treatment list. That's a hint that you're in a multi-factor setting. And there's some advantages that we'll get to see, especially in the analysis towards the end of today's session on why would it matter. You can just throw it in as an RCB and run analysis and whatever, but we can instead, as set up as a multi-factor design, then you can look at different cross sections of the data. You can say, well, regardless of my particular product, did one tillage type do better than another? Or on the flip side, this particular product, was that better than another product, irrespective of which tillage type I had? So we'll see that in our analysis. You can get to see different cross sections of data and learn a little more about what actually occurred, as opposed to just a straight list in an RCB, and you're just comparing treatment 1 versus treatment 6, and they're almost too specific, if you will. So with that basic definition of factorials in mind, we'll go back here to the list to just describe kind of the different flavors of a multi-factor design that we can have in ARM. So the factorial, we have two different types of factorials, just depending on how the plots will be arranged in the field. So the RCB, if you're doing blocking in the field, then you would want the factorial RCB. We did add the factorial CRD, the completely random design, somewhat more recently. That was coming from greenhouses and different research where you don't have to block. You know, and you're doing pots in a greenhouse, of course, there is no reason you would have to block. They can sit wherever. They're kind of their own little unit, so there is no blocking that has to take place. So the CRD is more appropriate in that situation. So just depending on the actual plot layout, how it'll be randomized, you have those two different options for a factorial. The other two are also the baseline is a factorial. It still has the multi-factor element to it, but there is some sort of restriction when it comes to laying out the plots in the field. So the split plot is that one of your two factors has some sort of limit. Maybe, and kind of the reason I use tillage as our example is if your equipment, something like the tillage equipment we're going to use, is maybe way too large to do plots kind of all scattered throughout the field. It's not practical. I have to drive the tractor down one whole range. I can't pick and pop and choose how things are tilled to make a truly random map like you would get in a factorial. So if something like that exists where logistically speaking, I can't have a totally random, there is some sort of pattern that just has to happen. I'm going to have all of the plots related to this one tillage type in one stretch in the field, just because that's the way I have to implement the study. That's really where the split plot comes into play. And when you do that, then your factor A is the factor that you can't randomize. That's the one that has some sort of limitation on it. The last one here is strip block or crisscross. So now, if in addition to that, the requirement of one particular factor, you have maybe some other constraint as well to consider. I don't remember if I've got a visualization in the help on that. It's a little hard to explain without it. Let's see, crisscross. So that one, just to compare with your split plot, you've got here, our example in help uses tillage as well. You're kind of stuck having them all grouped together. The strip block takes that one further and says, in addition to them all having to be linked, I can't even have them on that same range, that same, I guess I call it a row, this whole stretch here in this one replicate. I can't have my replicate all just next to each other. There's some other constraint that makes me need to drop each one of them in a separate row here. And so now you have your replicate kind of put this way instead. So that's kind of just one more layer if I'm limited somehow again. That is the strip block design. Little less common, I would say. It seems the split plot is the most common, but just depending on what you're limited to, the choosing this option is going to help us in the trial map, in the randomization process, because ARM then understands the restriction that we have and can make sure the map fits that design. And also as a result, then the impact in the analysis is the statistics also knows the way things have to be arranged. And so then the analysis can be smarter, if you will, for this scenario that we had to have. So that's a rundown of the factorials. Today's example here, I will stick with the split plot. Again, that way we can kind of show in the trial map what's interesting about a split plot design. The factorials are much easier as far as the randomization goes. There's really nothing too special there. So we'll do the more common special example with the split plot. All right. So once I've chosen my design here, we've kind of introduced this concept of the factors. And ARM can support 2 or 3 factors. I'm going to stick with the basic 2 factors here. And so we have factor A and factor B is kind of what we refer to them as. And this first box is just to describe the factor. What category is it? And so we do have a list associated with that. You don't have to use it, but in my case, I do have tillage type as an option in here. So I can have kind of a standard code. You'll notice down here, there is also the treatment types. So when we get to filling in the treatments editor, if you choose one of these, the treatments editor will pre-fill with that type, which I don't have a tillage specifically. Cultural practice we could use, probably be the closest one. So I'm going to choose tillage type. That best kind of describes what my goal is here with factor A. And then you would fill in the number of levels. So that's how many different, in my case, types of tillage methods that we are studying. And in my example, I think we'll use 3 types. Then factor B, that would be my product, or more specifically, we'll call it herbicide. So I'm going to go down to the list of treatment types. So that way it'll kind of pre-fill with my herbicide list. And so that's my second factor. And we'll say I've got four products that are what we're interested in. So as an end result, in our trial, we eventually will have 3 times 4 or 12 total treatments is what we'll end up with. So that's about all we really have to do here in the protocol settings to get this started. Like I said, it makes sense. You want to get into the settings and get the design set before the protocol is initiated. So that way our treatments editor will be set up for us. So I'm going to click OK and create our protocol. And you'll notice not much is really different in the protocol for a multi-factor other than the treatments editor. And so what we have are different sections in the treatments editor now. Instead of just one regular list that you're maybe used to, we have different sections for us to describe our levels. So what I'm going to do here is, instead of building the classic treatment list, we're really filling in the details about the factors that we are testing. And I'm not very original, so I'm just going to call this tillage 1, tillage 2, and tillage 3. You would, of course, have a description, something that isn't a product. Most of this information doesn't apply. You don't have a formulation for a tillage, so it makes sense a lot of times that you have at least one of these sections might not have much to it, but you would use the treatment name as kind of the simple description of what that is. Because in the end, we will have a list of treatments, and it'll take product 1 on tillage 1, product 2 on tillage 1, product 3 on tillage 1. So that name here that you enter will be seen a lot in the final treatment list. So be descriptive, and really maybe is only the treatment name might be all that actually has to get filled in in some of those cases. Now, obviously, for our herbicide product, totally different ballgame. That one, we would want to use our product list, fill in a lot of details that we have. And I might just grab, these are just our default products. I'm just going to go down the list and grab a few different random ones. Maybe we'll try to do A, B, and C just so they all look different enough. Since they don't really mean a whole lot to us anyway, let's pick one that's got a C in it and see if we have a product that starts with D. Perfect. So those are the descriptions for our factored levels. And so again, we will end up with 3 times 4, 12 actual products when we're done. There is one last category here for comparison treatments. So this, I don't know how common they might be in design setup, but the idea here is if you have some sort of treatment that is going to be in the trial but doesn't fit in the factorial, maybe it's just an untreated check that isn't part of that main factorial design, but you want that check present in the trial, or some standard, whatever the reason might be. That's where you would put in a comparison treatment. So it's not going to be randomized. I'm just going to call this comparison treatment, just so we can see kind of how it stands out in the end. It doesn't fit in with the randomization. We'll see when we see how a split plot is randomized. This treatment will just be at the very end of the replicate in every replicate, and it's just kind of outside of that realm of our main design. But sometimes it matters, and sometimes you want that there. So maybe it's a local standard. These are all the products we care about, and it'd be nice to just kind of mathematically compare to what the standard is. Once we decide through this factorial combination, we kind of get a winner, if you will, of what's the best one. It'd be handy to compare that to this standard product. So we want that in our trial. Will be an example I've heard. I don't know if there's other really good examples of where that gets done out in the real world, if you will. But we'll bring him along just so we can demonstrate what it looks like if you do have a comparison treatment. It might not be too often that you do. But one note kind of related to every so often we get questions where they have the check in the comparison treatment versus maybe it belongs somewhere in your factorial. And the question usually kind of ends up with, I'm not having the right number of plots when I go to randomize, or can this treatment list be a factorial design? And the trouble is not every combination of your different factors are in the trial. And that is kind of one requirement that ARM has in setting up these factorial designs, is that you do have to have, you can't just say, well, I don't have enough Canon product to be on all three tillage. So my plan was just to put it with number 1 and 2. And we'll just leave that one off because I can, I only have enough product, or whatever the reason is why you're trying to limit down. And so maybe instead of having 12, I only have 11 treatments in my list that I want to actually have in my trial. The way ARM is set up, the design, all the statistics in the end, all kind of require that you have all combinations. If you've got it in here, we're going to do all of the combinations. So the workaround is if I just can't do all 12, I have to have 11. The workaround is to fill in ARM with the full list, and then when you get to the trial, you'll have the one treatment. We'll say treatment number 12 isn't real in that sense, and you would just put in missing data points then for the plots that ARM is trying to have in the trial, but it isn't really actually ever been planted, ever been applied. Just use missing data points then, and that way the statistics can all do its thing. It'll just adjust for the missing data, and everything else will be happy because you do have the multi-factor still available. So that's just kind of a common question that we see. And just based on the math, based on the statistics, kind of locked in to having to have every combination, at least at this point in time. All right, so we already kind of talked about this, the difference between the factorial RCB and the CRD. But I did want to show one other function here while we're in the protocol, and kind of a 2-for-1 here. First, just to borrow this screenshot really to show what I mean when we're going to create the trial. And I've talked about how the factors are multiplied out. This is just kind of a nice illustration maybe to show what we'll end up with. So the full real treatment list looks more like what's on the right here. You have a bunch of different treatments. And this image on the left is what we had in the protocol, what we just filled out together. And just kind of trying to visualize what will actually happen in the trial, taking that tillage 1 and pairing it with your first herbicide, the Accord in this case is the one I grabbed, and that creates your true treatment number 1. And then treatment 2 is that same tillage, but with the second product. So you end up with every combination of tillage 1 plus our 4 different products. And then we repeat that process again, starting tillage 2. Now that should be paired with all 4 of the products. So we get that multiplied out list. And that typically is done when you go from the protocol into the trial. That's the process that happens. And so once we make it into the trial, then we have that full list in the trial. There is a command that we've added a little more recently that within the protocol, you can convert to this multiplied out treatment list. And so that's just under the tools menu. The command is multiply out treatments. So it really just does this conversion for us while we're still in the protocol. The one trick, the one gotcha there that you want to make sure of is that you can't go backwards. once you kind of convert the full list, then ARM can't reshuffle it back to the way it was. So you want to make sure you've filled in your factors the way you want them, want them to before you go ahead and do that. But this is kind of showing one reason, kind of the reason we added this, because there are a couple times where you really almost need to have that in place. And so this example here is showing 3 different products that each product kind of has its own rate that it would be applied as its kind of baseline rate. But the trouble is the design, we're wanting to test each of those products at a low, medium, and high rate. But the numbers aren't the same for each product. So I can't simply enter in a rate of 3 pounds per acre, 4 and 5, and have accord be at 3, 4, 5, and Brominal at 3, 4, 5. That's not how the rates actually work. It's more of a multiplier where I can describe that for accord, that baseline, the low rate is a 2, and then I want it to increase from there. Whereas the Brominal, I need to start at 3, and then it would grow from there. And so you end up with this kind of inability to put in the actual rate that will get used when things are just multiplied out. So a situation like that, we can then, in the protocol still, do this multiplication. And so then you get this list like we have, and now while still in the protocol, so if I'm a sponsor and going to send this trial out to different trialists, there's this extra communication that I have to have, and I have to hope that the trialist understands and gets all the numbers right, because if they have the rates wrong, the study's worthless. So it would be much better if me as the sponsor can get this all set up correctly from the get-go. So the protocol, I will do this step, multiply everything out. And so now I get this list, and I can now edit. I can go in and say, all right, well, this is actually the multiplier, the low rate. So the 2 is actually correct. The second treatment, though, I'll take that 2 times 1.5. So I need to manually adjust this 2 up to a 3, and then adjust this 2 up to a 4. And then I'll actually have the right rates in my study, so that way when I pass this on to the trialist, they'll have the right rates, and I can be confident that things will be applied the way that they should. And so that shows kind of after cleaning it up as a sponsor, I can get this cleaned up. It's very clear what rate should be done. And you can see that, the Brominal has to be a 6. The Cannon is at a 3. So the numbers are different for each one, but it is a valid factorial design. It's just that the rate number numerically isn't the same, but it still is the category of high or category of medium. And so that's the particular scenario of why you'd maybe want to multiply things out. Be able to clean things up in the protocol, so that way every trialist starts with the right list, instead of having to explain those instructions to every trialist and hope they all understand and get it updated the way that they would want. All right, so just real quick, there's not a whole lot to show with that command, but we'll do it here. Just tools, and then multiply out treatments. And it's just going to say, all right, we need to save the protocol before we do this, because it's got to do the kind of conversion here. So I'm going to, I haven't saved this yet, so I'll just drop it on my desktop. Obviously, you would want to save it in much better method than I am here. All right, so here it is, multiply things out. It's also offering to help us with something. This is a tip that In our case, doesn't really apply. It's offering to copy this formulation information up to our tillage row, which wouldn't make any sense in our case. So I'm going to say no. It is a nice shortcut if you have like product times rate, but in this case, it would not be very helpful. So now we have that multiplied out list, 1 through 12, and then there's that comparison treatment just hangs out at the bottom as number 13. So it can be useful if you just kind of want to make sure you've done it right. So if, hey, I've got my list written down of what I imagine it'll look like in the trial, this can be handy just to be like, oh, okay, this is what it will look like when the trial's created. That looks good. Or, oh no, I did something wrong. I left out a product. Maybe I'm supposed to have 5 for my factor B or something like that. You can, as long as you haven't changed anything yet, you can use the undo, and that'll bring it back to the way it was. Again, that's only while you're in this session here. If I had saved it, closed it, moved on, come back tomorrow, then I'm kind of stuck. So that's why there's just that. We're going to save it. We're going to convert it. A little bit of a formal process there. Okay, so that covers the protocol side of the multi-factor. Everything else we saw, the protocol description is the same, assessment data is the same. Really is just kind of setting up your treatments. So now moving on to the randomizations, when we actually create a trial. And a very original trial ID for our trial we'll create. Now with the trial map here, like we said, if you're doing a factorial RCB, the map's going to look almost the same. Not a whole lot to really consider there. It's going to be very much similar to a regular RCB as far as the trial map goes, or the CRD for that matter too. But what you will have in any of these factorial is on the properties panel, there is an additional coloring option. And you can see that on display here. I am coloring by factor A. So factor A, which you can see down here in the level description, was our tillage types. The green is our tillage number 2. And you can see because of our split plot design that they're kind of grouped together. So if I had a factorial design, they would be scattered all throughout this replicate. There would be no pattern to it. It's all random. But because we have a factorial, or excuse me, a split plot, we have that limitation. I have to group the tillages together within my replicate. So replicate 1 here, we have this restriction. My tillage has to be next to each other. Within that, the B's are all random. You can see how the selection of products, the arrangement of products within that set of 4 is random. So we do have everything, as much randomization as we can achieve, essentially. And then within each replicate, you can see that the selection of which A group, which tillage group, is different as well. So we can choose and then have them in different spots throughout each replicate. So again, kind of trying to get many things random as we can without with fitting in our restrictions. I just saw a question here that popped up. An issue here with the treatment type. So what I would do is just delete out that TIL out of the treatment type for each of those rows and just leave them blank. I think mine was blank. I'm not sure why Yeah, you can leave it blank. Obviously, typically when you're filling in treatments, you would use the type to give you the appropriate list, but something like this where we're not looking for products, you can leave that type blank. And I think that's what ARM was complaining about, is if you don't put in a real type, it's not going to be able to find the right list. So just clear those out and hopefully it lets you create that trial. So here's our layout, I guess, for our split plot design. Again, this color by, and you can change the different factors to see each. In this case, now we're coloring the factor B's, which would be our products. And those are pretty random in this case because we didn't have that restriction with the split plot on how those are arranged. So those are pretty random, but it's kind of nice to see that grouping in a split plot because that's really what's happening. What's special for a split plot design is that requirement within our replicate to group them together. We also have another option here in the drag and drop function, this auto select for move. Typically, you can move around replicates, you can change the treatment selection, you can move individual plots. We also now in a factorial have the ability to move a main unit. So when I turn that on, I'll just click on plot 101 to show you what gets selected in a main unit. That's our 4-pack, if you will, the set of all of our A2s. So logically, we had to group these together because of our split plot design. It all is this one tillage type that our equipment is just not going to let us randomize. And so I can select that as a whole and I can move it around. So maybe what I want is to line up the treatment or the tillage 2 all should be in one stretch. So I can manually adjust the map that way by just moving around those main units to match my requirement. In addition to just within my replicate, I actually, across replicates, I have to drive that tractor down there. There's just no way that I can adjust even in between replicates. So that's just, I'm gonna have to have it all the way down. And there's actually an option to automate that idea. If I go into the settings, this will take us into the protocol settings, or if I was already in the trial, same dialogue, same set of options in the trial. And the very bottom option here is to not randomize one unit for a split plot design. So if I set that to my tillage type, then within that replicate, it'll always have A1 first, and then B2, and then B3, or A1, A2, A3 in that map. So it'll generate a new map for me. And here I didn't have to do any dragging and dropping. You can see it always had that first one first. So you end up with that nice whole swath, if you will, set up the way that you have to. So that's a way to kind of automate that. If that's a requirement that you have. Just go to settings to set up the split plot in that way. Obviously, if you have control, if you can randomize, you're a little better off from a design standpoint. But if you're limited, that's a good way to get there on the map. Sometimes there's questions about block size as well. So maybe my replicate can't be quite this long. So we have the block size option. The trouble is we're a little bit limited. So if I wanted to split it in half and go 6, the split plot design is somewhat limited. So it's ARM is going to give us a little grief to say, hey, we can't split it up. I think philosophically, we've a question we get often enough that I've asked our statistician if, just philosophically, shouldn't there be some block sizes that would be kind of okay, like that 3, so I can have them side by side. He said, philosophically, it probably would be okay to do that, but we'd have to get the logic right, especially here now that we have this 13th treatment. It gets kind of messy. How am I going to actually split this up evenly? So it's a little more challenging to get the numbers right. So at the moment, if you're in a split plot, ARM is going to be a little bit picky about how small of a block size you can get. But to work around that, you certainly can use the auto select for move. If you're wanting to move, all 4 of them together, you can do a drag and drop. And if you drop it into like an empty spot, it'll create a separate row. So if I needed to make my replicate, a little more square or something, and maybe this is what it ends up like. I don't know what would be the most realistic thing, but maybe I need to arrange it that way. And then I can get a little more fine tooth, switch over to plot, and then you can kind of move things where you would need them to be. Kind of that principle versus practice, I guess, where the design will take you so far, and then sometimes you just have to fit things in the way they have to be fit in. And so ARM does allow that kind of manual adjustment when you need it to. And just to highlight, that's all in one replicate. So then I'd probably need to repeat that for each of these other replicates. I can insert rows to be able to fit things in where they need to. So that's kind of the workaround there. If you're limited in where things have to go, you can always drag and drop to get things where they should be. All right, so we're just going to call that good. Now this is a little bit of a mess, but we'll accept the map as it is. Move into the trial. And it's asking that again, just because now it's multiplying out that list. And just like before, I'm going to say no. So now we're in the trial. And so we can see that multiplied out list that we kind of already got a preview for. Really the only difference all the way to the right on the treatments editor, we do have 2 other columns, the factor ID and the level number. And so that is kind of what we saw on the trial map a moment ago. That's just kind of designating where did this tillage 1 come from. That was our factor A, the first item we listed in our factor A list. And then we also, we also took factor B, the first level of factor B, to make this treatment 1 as an entity. So sometimes there's a question that, hey, I've got this trial. I initially set it up as an RCB. Then I realized, oh, wait, I think it's a multi-factor. Is there a way to convert from an RCB to a multi-factor? And really, it's a little bit manual. What you would do is you would first go into your settings and you would change the design, and set it to be your factorial or whatever. And once you do that, then these 2 columns will appear. And then you would need to kind of manually fill them in to hook up the particular components to the factor information. So it is possible, but it just kind of takes those 2 steps. And you do want to make sure that you have at least 2 rows for each treatment. So sometimes you might have to add some rows to make sure that you're designating the information about both factor levels. So that would be a way to kind of reverse engineer without having to start all the way over. One more thing I neglected on the trial map. Let's go back to that trial map. I didn't specifically point out the comparison treatment. So here, when I was colored by factor A, just to point out that that comparison treatment is just over here on the right. It's outside of this structure of the multi-factor. ARM doesn't really know where it belongs. It's just hanging out. So it ends up always on the far right in your replicate. Certainly you can move it around if you need to, kind of like I did here. Maybe with each replicate, you move it to a slightly different spot or whatever your requirement is. But just that, again, that comparison treatment there, he's not part of the design. He doesn't get put in with everything else. But obviously is there. He's part of the trial. You just kind of got to be aware that it just gets dropped off at the end. Okay. Again, other than that treatment list, there's really nothing fundamentally different. You'll even see in the assessment data, everything looks the same. We're just dealing with treatment numbers and plot numbers. There's nothing special or different here in data entry, in the site description. Everything's really the same. It's just a matter of setting up the treatment list that's different, and that trial map, how things are put into place. So our last topic then is the analysis. And I'm just going to cheat and go find a trial here in our tutorial list that has data in it, instead of just randomly mashing some data, which we could do if I needed to. So I've turned on the tutorial checkbox down here at the bottom to show the kind of the standard list of a bunch of trials that everyone has in their ARMs. And most of these are named to try to show what it's trying to illustrate. And in this case, I've got one for a split plot. And in this case, there's both a protocol and a trial. So I'm going to make sure to open up the trial because that will have the data for us. And just for our frame of reference, let's go into the settings to check the design. This is kind of matching that previous screenshot or other example where we've got products, 3 different products, and we're testing them at 3 different rates. So kind of a simple example. So 3 products, 3 rates. We have 9 different treatments, and then there's an untreated check as a comparison treatment. So that is the setup here. And we've got control ratings. Nothing too unusual or exciting. But for our reporting, we've got, instead of the AOV means table, which you certainly can generate for a multi-factor design, it will not be any different whether this was set up as a multi-factor or an RCB. It will treat it as if it's just an RCB design. There's nothing special here related to multi-factor if you're doing the AOV means table. It's really being run as an RCB design, none of the multi-factor considerations at all. So instead, we have a separate report, it's right underneath the AOV means, called factorial AOV table. Very similar structure, so it'll look pretty familiar. It's got a lot of the same options as your AOV, so it should be fairly familiar. A lot of the general summary options apply as well, but we'll preview here on the screen so we can see everything. There's obviously some fundamental differences here. So I'm going to zoom in a little here so we can see Similar structure, every assessment column is on this report. We have the header on top, and then the main analysis in the middle. But what's different is we have different tables for different analyses. So instead of just your treatment list, first thing we get is just replicate means. And just get a sense of how consistent the replicates were. But more impactful is we have a table of factor A means. So this is the cross section of factor A that combines the factor B. So in this case, it is combining all of the data for this product. When we looked at our treatment list, there was a low, medium, and high rate that we put out with this Accord product. We're going to combine all three of those together for I guess it'd be a grand mean of 61.8. We do that with each and every product. And so that's kind of one cross section that we can see. And we can do statistics, run a mean comparison to see, was there a difference in product? Ignoring the rates, combining the rates, I guess would be maybe more technically correct. Was there a difference in the product? Same idea with the table of B means. Now we're looking at low rate versus medium rate versus high rate and combining all of the different products. So same thing, means, mean separation with the statistics. So we can, again, learn a little more on what differences there were since we had this pattern. And then we have the full list, A times B, every combination, which kind of matches that RCB design, everything all separated out. Was there a difference, and how much separation did we see? Same thing there with statistics. And we have kind of the full AOV table. You can see how, because we're in the multi-factor, we get to, in our analysis of variance, we can learn a little more. We can split things out a little more because we have these factors. And one thing that might be interesting here is looking at interaction, the A and B. Was there significant interaction between our A and our B levels? So you can peel out that p-value there. It can be somewhat interesting as well, depending on your design, your experiment. So that's kind of just the big difference, is to realize that there is a separate report. And I'll just go back just to hammer that home. There is a separate report for a factorial design. Any of these multi-factor designs, split plot, the strip block, and then the factorial. One option here I just wanted to highlight, which I actually have in a PowerPoint, was just to show in the listing. Sorry, I'll go back to ARM here real quick. On the report of what these actually are. You have some control, some choice on as to what shows up here. And that's what I'm demonstrating here on the PowerPoint, is this option multi-factor view. You can decide what should show up. And just sometimes depending on what all you have going on in that treatment list, it might be messier than you'd like. And so previously, the kind of the default is just whatever is in the trial. That's what gets pulled in. But now there's also this from level description, and that comes from the trial map. So when we were first looking at the trial map, you can enter in this description that doesn't have to match how you filled it in the treatments list, for example. You might have just too much information, kind of gets crowded. This description you can just simplify. And then this, whatever is entered here, if you choose this option from level description, that's the text, that's the description that gets used on the report. So if I go back to ARM here, that's what's getting used, is that piece of information there, which doesn't necessarily have to be kind of what's in that treatment list. In my case, in this one, it's pretty straightforward. It's not really hard. There's not a lot of information, but sometimes it's maybe overkill what all is there. So just again on that trial map, the level description, which is separate from the treatment description in most studies, there's a separate section that describes your factor levels. And you can change this. I'll just pretend that I want it super simple. If I do that, then on my report, assuming I'm using my level description, that's all that gets referenced now, is that text there that I had on the trial map instead of what's from treatments. So that's somewhat new option there. And just in general, if you haven't used this before, there is a reset button. So this can build from your treatment list whatever information I want to pull in. In this case, I probably want to just pull in the treatment name, but I could, and just to show, I could grab like the rate number as well if I want. And that'll then extract from the treatments editor all the information there. In this case, you can tell it makes a little bit of a mess, which would be maybe why you'd want to simplify it. All right, well, that's kind of the end of my list here. We kind of covered everything from setting up the protocol into the trial map, which again, today's demonstration was specific for the split plot, a little more complicated than other factorial designs. And then we saw at the end, running the factorial AOV report gives you that separate analysis. This topic is pretty specialized, if you will. It's always just everyone's slightly different, trying to get multi-factors put in. If you are having any troubles trying to get it set up in your ARM, not quite sure, trial map isn't behaving the way you want it to, things like that, feel free to reach out, send us an email. It's usually helpful, just send us the Excel sheet that you have a picture of what you're trying to get to, and then your trial or your protocol that you're trying to get to work, and we can kind of step through it with you to figure out what needs to be done to get ARM to match what you're doing out in the trial. So thank you all for attending, and hopefully we'll be seeing you again soon.